welcome to the video tutorial for the lab on patterns of crustal activity. We are going to be analyzing earthquake and volcano location data in this lab activity. First, we're going to plot their locations all around the world for both earthquakes and volcanoes, and then we'll be able to compare those locations to each other. And to take a step further, we're going to compare those locations to the tectonic plates map on page 5 in your Earth Science reference table to see what kind of patterns emerge and how we can understand the dynamics involved in plate tectonics. So, before we get cruising too far along, I just want to take this moment to add a little to this diagram. These convection currents that we see here moving around in the mantle, they're really the whole driving mechanism behind plate tectonics. So it's really important that we understand that it's that material moving around inside the Earth below these mid-ocean ridge locations. This mid-ocean ridge in this box here, so if we follow the lines that draw it out, this box fits inside of that box, right? So you can see right at the mid-ocean ridge there's magma coming up from below. It's forcing its way out of the ridge. It's going to promote some spreading, and then these convection currents going, up there and then out and away on each side of the ridge, those are going to drag along the bottom of the oceanic crust as well and further drive the whole process. All right. So that's kind of our vocabulary there. They're at the mid-ocean ridges, being driven, that spreading being driven by mantle convection, and all this getting into the idea about how plate tectonics is about these large slabs of rock known as plates, how those are going to be moving around, creating things over time. All right. So here we go. First activity: earthquakes and volcanoes around the world. What we see in this is that we've got triangles are the volcanoes, and it looks like circles are going to represent the earthquakes. And so we are going to find them on that map. The data the images are already there, the plots are already there. And so if we're going to use red, do volcanoes first. Right, so each triangle is going to represent a volcano, and I'm going to put a little dot on the top of each one of them. As I do this, I'm going to try and hit each one, but it's more important that we're establishing the general regions where these are occurring. Not that I hit every exact specific triangle. I'm trying my best. A whole lot of them through there, and really all down this whole region. Okay. And looks like there's a few more over here in Italy. And that's going to be all our volcanoes. Switch it up to blue, and those are going to be the earthquake locations, the epicenters. And so there's a lot more of these to do. Again, we just want to, you can see that there's clearly locations where these things are occurring. They tend to be near each other. In fact, it looks like everywhere where there's volcano data, there's also earthquake data. A lot of locations that only have earthquake data, but if there is a volcano, there's definitely earthquakes nearby or at that same site. It's got to do with the magma that would be blasting around. That's what's causing the earthquakes that we see in those regions. Alright. There we go. And so there's that segment of the map. So we've done numbers 1 and 2 in part 1 here, and the last thing we're asked to do is that we're going to connect the circles for the earthquakes in blue, and we're going to connect the triangles with red to represent those volcanoes. So this. Alright, so that I would think fairly connects that data. And then if we do the blue for the earthquakes here, and that'll do it. Alright, so um, that is generally your zones of the Earth that have your earthquake and your volcano data. So you take a step back, you can take in that pattern and say, okay, so there's clearly something happening in those locations where all that is happening that should provide us an explanation for all the activity. And when we compare that map to this map, which is page 5 in your Earth Science Reference Table, it's really clear to see. Look at that shape around the Pacific Ocean, and through in around South America with the Nazca Plate. If you look at all that in the middle of the Atlantic Ocean, the Mid-Atlantic Ridge there, right, well, hey, look, there's those same shapes. Okay, so really what your questions are here for the part 1 discussion questions are going to be about making those connections between this map and the reference table page 5 map. And I'm going to leave you guys to being able to do that. If you have any questions, please post them in the discussion board on Schoology. Alright, part 2 here is about getting to know the tectonic plates. And so what we're going to start by doing is highlighting the names on this tectonic plates map here. We're going to highlight the names of each of these different features in a different color. So we'll go for green. Once the trenches in green. Okay, so I'm going to come down here. I'm going to find all the things that say trench on them. And there's the Aleutian Trench up here. That's where all those volcanoes were. Right, those islands, the Aleutian Islands, are found there at the Aleutian Trench. We've got the Mariana Trench over here. Famous. And then we've got the Peru-Chile Trench over here on the west coast of South America. And that is all the trenches. Okay. Here, the next one, we wanted the hotspot names to be in pink. And so, okay, hotspots are going into pink. And here we go. So we got the Hawaii hotspot, Yellowstone, the Galapagos, Easter Island. We've got Beauvais, St. Helena, Canary, Iceland, Tasman. And I believe that is all of the hotspots. Yep, okay. And now the ocean ridges, drew in blue. Okay, so do those in blue. And okay, so the mid-ocean ridges. These are these divergent boundaries. Right? Mid-ocean ridges and divergent plate boundaries. And so this whole pattern is the pattern of the ridge. So while the Mid-Atlantic is written here and here, that entire pattern is the Mid-Atlantic ridge, right? And so again, we'll find the names and highlight the names here. They are typically named after the ocean they're in the middle of. Makes sense. And so I do like to go a step further and highlight the entire divergent boundary to connect these names and locations. say, wow, look at that. There's a lot of ocean ridge material out there. And cool. All right. The last one we needed was, well, I think that was actually the last one we had to do here, right? Yep. So the next task is asking us to draw with red the locations of the hotspots. So we did their names in pink, and what we're going to do is color in those little star blast patterns. I'm going to color those in with the red. So, Yellowstone, Hawaii, Galapagos, Easter Island, Iceland, Canary, St. Helena, Beauvais, and Tasman. Okay. There we go. Alright, and so that's essentially everything that we're going to have to do in terms of marking up the map. Alright, so what we need to do now moving forward is to analyze its features. And so I'm gonna leave a lot of this to you. I'll show you, an initial one of what we're talking about here. If we're gonna name the hotspots in these locations, we got the continental United States, right? And you can see there's going to be other locations you're going to be asked to do the same exact type of thing on. But if we went to the continental United States, pick a thinner one here, would be generally this area here. Right? So the one that's inside of that region is the Yellowstone hotspot. And so that's what we'd be looking to record in this space up here, would be the Yellowstone. Right? And so find the other ones for these other plates that are being asked for here, and I'm going to leave you guys to doing that on your own. Excuse me. The rest of these that are on this page are going to be asking you really mostly about the arrows, and so I do want to introduce this for you, and then I'll let you apply it to the rest of these. So generally speaking, the arrows are going to be about the relative motion at a plate boundary. So when we look at the various types of plate boundaries that are on here, from a transform plate boundary to a divergent plate boundary to a convergent plate boundary, the arrows are moving relatively different at each type. So when you're asked in these questions to identify that, that's what you're going to have to do. All right. So case in point, if we were to go to the trenches, the arrows at the trenches, when you look at those are all the trenches we did in green. You can look at those arrows, you can find that type of arrow on the key on the bottom, and you should be able to compartmentalize each of those various types. So on the back page, it's very similar exercise here in terms of just interpreting this map. So I'll model the first one for you. So the two plates that are on either side of these locations. So the first one we're given is the Aleutian Trench. And if we're looking at the map of the Aleutian Trench, that's the one up there in the northern part of the Pacific Ocean. And so if I'll do this in red. So for where the Aleutian Trench is here, the plate that is, this arrow's portion of the plate is the Pacific plate. Right, we're on that side of the boundary. On the northern side of the boundary, this arrow is represented. We could not cross this 140 degree uncertain or complex boundary, because then this side is the Eurasian plate. So if we kind of travel over this way, we can see, oh, there we go, we're on the North American plate that's on the northern portion of the Aleutian Trench's boundary. So those are your two plates, the Pacific and the North American. So these are pretty similar use of the key and the things that I just introduced. So have at it and let me know if you have any questions on the discussion board, as always, in Schoology. Hope this helps.